Hello, hello. It is me, Ugo, and I am in a much better mood than I was in the previous problem. Oh my god. Sorry. Uh, this problem, minimum required characters to turn it into a palindrome. Oh my god. That just, I don't know. My brain just died. My brain died in that moment. I did not like that problem at all. Especially, I really did not like the formatting of everything. The fact that you had to turn in the interview bit submission before you even get the resources in the next module, which is like 40 minutes long in a play posit that you had to watch. You don't get these resources until after you do that one, I'm pretty sure. So it's like why is it over here? Why is it not right here? It's and then this the hint was not working. The hint was not working for me. The hint was like bugging, so I yeah, I couldn't understand it when I searched things up, so I had a very hard time with this one, but I'm finally done with it, and this is the very end. I'm done with 301 now. Pascal's triangle is the final thing, and we're over with it. Everything else is just so. This is like a celebratory moment for me. I'm happy. And Pascal's triangle was a lot easier. I kind of thought it was gonna be hard because I saw someone back over here. I think it was in the something about paths, unique paths. I think in the understand. I think I could probably show you. Not the understand. The discussion. There was one of the discussions in it. In the unique paths, there was a discussion. Was it understand and match or was it the plan? Yeah, Fuqua said that this is a classic dynamic programming problem like Pascal's triangle or combinatorics. And that scared me. because unique paths took me quite a bit too. It was very difficult, and my solution was very slow, and it wasn't actually a dynamic programming solution. The dynamic programming solution is much better. My solution was O of n squared, and dynamic programming is I think O of n and O of n space. So yeah, I was worried going into this, but Pascal's triangle was actually pretty easy. So essentially in Pascal's triangle, what you're given is an integer number that represents the number of rows that we want, and we're supposed to basically just build the triangle. Pascal's triangle is a very unique mathematical shape. I know that it's a math thing because I remember hearing about it in in the in my calculus class one time. I forgot why, but it's like a mathematical thing. Don't know when it's used. I know it's used for something. Applies to all real numbers and negative numbers to help Newton find the infinite series of square root function. Well, that's cool. That's probably why it came up in calculus. But yeah, so you're given the number of rows we want, and we're just supposed to build that number of rows of the triangle. And Pascal's triangle is a triangle shape where the outer edges are all one, and everything within it is the sum of the two numbers directly above it. So if we look right here, we have all the ones on the outside, and then this one's going to be 1 plus 1. Then if we continue going further down, so we have a 2 here now, we're going to have 1 plus 2, and then 2 plus 1, and then 1 plus 3, 3 plus 3, and 3 plus 1. And that's how we get our 5 column, or rows, 5 rows. So, I kind of just thought, okay, nice, simple. Let me go to my solutions or submissions. So, this is my original one. My original solution was just, we're going to create the triangle. And I thought maybe because this one was the first one in the base case, the tip, that maybe we would have to create that as the base scenario. When I tried doing this without it, it would have a error because there was nothing inside of the list. So if we look at this right now, it just fails because of the out of index, which makes sense. I tried playing around with it and fixing it, but I couldn't get it to fix, or I couldn't fix it. So at the end, basically what happens is we end up appending one more of the tip. So it's gonna be like 1 1 and then 1 1 1 2 1, and then it goes on to the Pascal's triangle. So I just had to pop out the first one afterwards. I did not really like this, but it worked basically. So essentially what we're doing is we started off with the triangle, and then we're going to go through each number of rows. The number that they provide us is one indexed. So if they give us 5, they want us to do 1, 2, 3, 4, 5, even though it's going to be from 0 to 4. So yeah, but rather than doing that, I did this because I wanted to include the 5th one because we had to have 5 elements in the last row. So then we do for I in range, or for j in range of I. I is going to be the current row number that we're on. And then we're going to check if we're at the edge. So if we're at the start or at the end, we're going to append 1. Otherwise, we're going to append the sum of the left upper cell and the number in the right upper cell. So we go up 1 row for both of them, and then we go backwards 1, and then we go to the current one. So if we look at this one, this would be index 1, right? And this is index 0 and index 1 of the other row. So we go back 1 row, which is I minus 1, and then this is index 0 and index 1, and we're trying to get index 1 of row 2. So that means we're going to get the previous cell in the previous row, and we're going to go to the previous row, and then we're going to go to the index before the current one, and then the current index. And that would give us our left and our right. And then we just append the sum of that to a row list, and that row list will be appended to the triangle at the end. And we just pop out the first one, so then we get rid of that little 1 right here that we needed at the start, and we return the triangle, and that worked. It worked, but I did not like the fact that I had to pop it. And I didn't like how big this was because it felt like we were essentially right here. All of this is just creating the row. So part of me was like, I can do better. Let me make it a list comprehension. And so I tried, but I wasn't able to get it to work immediately. And I just started plugging numbers away at it low key. So that's when I got this, where what we do is we get the previous row, and then we just go through the J to the previous row. Like I said, I was just throwing numbers at it because I couldn't get it to work. So I'm not going to explain this one because I don't fully understand the list comprehension. I was just throwing numbers to make it work, and it worked eventually. I know it says the memory is beaten, but both of them pretty much use the same memory. So this is essentially the same solution. It just changes the indices a little bit. So what we're doing here is we're going to be starting the triangle at the same spot, but this time we're just going from 1 to the number of rows because we already checked the 0th index, and we technically don't have to go all the way up to the number of rows because I realized like we need to stop at the row number, or like we already did 1. So we're just going from there to the end, and since like lists are 0 index, we don't really have to worry about it. We're still going to get that number of rows anyways, so it doesn't matter. So I just get the previous row really quickly, nice and easy. So then I avoid having some 2D indices and having to have some weird I variable and all that in there. It's gross. Don't like it. I think this makes it a lot clearer to have the previous row as a list of its own really quickly. And then we're just going to get the one on the left of it and the one to the right. So like what I was saying earlier. So the upper left and the upper right. Upper right is just the current index, and then the upper left is going to be the index before the one that we're at. And we're going to just go from 1 to the length of the previous row. And the reason we do this is because we're ignoring the last one right here. So this is not including the last index of the previous row, or it is including it, but it's excluding the first one. And the reason we do this is because we know that the first one's always going to be 1, but we do know that the last one's going to be 1, but because of the way that we're doing using the indices, we're going to end up just getting it from there. So it's like this -1 to prevent it from going out of the indices or going to -1. We're going to start it at 1. And then we're going to go up to previous length, the length of the previous row. And that's going to be here. So we don't have to worry about that because it's basically like we're going like this. So at 1, what's it called? At 1, well, the 1 right here is getting added to it from the start. And then we start at 2. And then 2 goes to j minus 1, which is right here. And j right here. And then we go to the next one. Wait. Yeah. No. Wait, this might be a bad example. So this is the first one. Then we go to the next one. We go to the previous and then the current one. Previous and then the current one. And then that's it. It stops right there. And then we add the last one at the end right here. Sorry, it's because this is kind of confusing me a little bit, but like why don't we subtract it by 1? But I think it's because it's not including it, so it's fine. And then we just append. Oh yeah, it's because the row above is smaller, so the length of it will end sooner. So even if we're at 2 right here, the length of this is 3. So once we try incrementing one more time, we're gonna be at 3. J is gonna be 3 right here, and 3 is not less than 3. So it's not gonna continue right here, and we just add the 1 at the end. So that's how it works. Sorry, I was thinking about it in my head a little earlier, and it just like disappeared from my mind, and I was trying to find it again. So yeah, and that's gonna be the new row, and the new row we're just appending that into the triangle, and then we just return the triangle. Nice and simple. The logic's there. Everything's clear. I think. I hope. And yeah, that's the solution for Pascal's triangle. It's pretty cool. I'm not sure if there's a faster solution. I don't think there is, because I mean, this makes it seem like there isn't. But yeah, that's pretty much it. I'm happy I finally finished 301. So that's that. Bye bye. Let's go.